My name is Leanne Gluck, and for the past 2 years, I've been working with an organization called America Makes. America Makes is the National Additive Manufacturing Institute based out of Youngstown, Ohio. It's a public-private partnership comprised of over 160 members from across industry, academia, nonprofit, and government, with a specific focus on advancing the acceleration and adoption of 3D printing technology in the U.S. And today, I'll be talking with you a little bit about 3D printing, specifically around some of the design implications of the technology. And the focus is really around 2 training offerings to help to think about how to integrate this technology into your value chain, whether for you as an individual or for your companies. So, what is 3D printing? Well, essentially 3D printing is a manufacturing technology that allows you to design something in a 3D software and then print it layer by layer by layer until the final product has emerged. And there's a number of different 3D printing technologies out there. I think over the past couple of years, we've become very familiarized with FDM and fused deposition modeling, the kind of MakerBot 3D printers that are out there. But there are a number of different technologies, and specifically to metal 3D printing, I wanted to highlight 3. One is powder bed fusion, which is additive manufacturing in which thermal energy selectively fuses regions of a powder bed. The second is directed energy deposition, and the third is binder jetting. And with binder jetting, you're using a liquid bonding agent to deposit joint powder materials. And so, for example, powder bed fusion, for example, the 3D Systems Pro X 320 prints in Ti 64, so using this technology to print in titanium. We're seeing a lot of advances in metal 3D printing over the past year specifically, and there are a lot of new companies like Desktop Metal, Markforged that are coming onto the market, providing solutions for metal 3D printing that are cheaper, faster, and produce quality parts that can be used specifically for end-use manufacturing. So, what are the materials that we can 3D print in? Well, if you would have asked me 5 years ago how many materials we could print in, I would have said about 60. Today, we can print in thousands of materials, and this includes a number of different metals like miraging steel, titanium, nickel alloy. It also includes things like ceramic. Recently I heard about calcium-infused ceramic to 3D print bone. But where we're seeing a lot of advances is in materials that are specifically developed and formulated to take advantage of 3D printing. So in the medical field, for example, a new material that is a gel that when 3D printed, it mimics cartilage. So, and in terms of the markets, there's broad adoption across, retail, dental, and medical. Automotive, aerospace, and defense are 3 of the kind of broadest markets that 3D printing is in, and many of you may be familiar with the aerospace industry. GE has done a lot to really let people know about the work that's being done with the GE LEAP engine and integrating 3D printing into planes and rockets. The Army is also, the Department of Defense has also invested heavily looking at things like repair, replacement, and refurbishment of parts, as well as building parts, with the Army, the Navy, and also using design optimization of 3D printing to help to support things that they produce. So why use 3D printing? Why use this additive technology as opposed to a formative or a subtractive or a traditional one? And I like to talk about the 3 C's of the why. And the first one is that leveraging the power of 3D printing, you can make items that are incredibly complex. So you can develop it with things like lattice structures, use biomimicry. If you go to the Arconic booth, they have a bracket where they've used some biomimicry and lattice and lightweighting to redesign a bracket. And you can see the difference between the original bracket and the light-weighted, optimized, redesigned bracket that are usually more complex, but much lighter, and equally, if not more, strong. The second is customization. So with 3D printing, we're able to do mass customization. The biggest example of this is in the dental industry. So many of you might not know that Invisalign braces, each one of those braces are 3D printed. Why? Because everybody's teeth are different. And so if we want to make something custom to each individual person in the room, we need a technology that can do that. And so this idea of one size fits none and developing things that are bespoke, developing things that are co-created with the customer and customized for the customer are advantages that 3D printing can allow. And finally is being able to build things in the cloud. So with 3D printing, you're designing something in a 3D file, and that 3D file essentially becomes the blueprint for what you're going to create. This means that you can co-create things. I can be in Germany and you can be in New York, and we can be working together on the same file. It also means I can reduce my inventory, because now if I have a part that I know will be easily producible by just printing it, I can keep that file in the cloud and then print it on demand. So it also helps to alleviate things like very expensive molds because you can use the software design to recreate that in the cloud. So these are just two examples of how this is currently being leveraged, both now and in the future. So Autodesk wanted to think about, well, how could we use lightweighting and lattice structures and design optimization for airplanes? And so they built this magnesium seat frame. You can see that they've used lattice structure to lightweight it. Or you can see that way. I'm pointing at my screen. And what they saw was radical reduction of the amount of material that the seat frame used, and because of that, incredible amount of fuel efficiency. A lighter seat frame uses less fuel. The second and most comprehensive one is GE. So you'll see up on the corner is the GE LEAP engine, the nozzle, the fuel nozzle that was kind of redesigned using design for function. GE is also using part consolidation. So in the corner is an example of taking something that used to be 242 parts and consolidating it into one part using 3D printing design. That means that instead of making, producing, and assembling 242 parts, you're now just creating one. They've also done this with an advanced turboprop engine, and in that case, it's 855 parts have been consolidated to 12. They've lightweighted the turboprop engine and seen reduction of emissions of 20% fuel burn. So again, that is decreasing costs as it relates to fuel. So we know that this is exciting and interesting, and everybody wants to recreate what GE is doing. But the question then becomes how? And so I believe, and many people believe, that workforce and education and training is a key way to introduce this technology into your value stream. And so I'm going to talk about kind of two ways of doing that. One is around supporting your manufacturing engineer, your product engineer, your materials engineer. And the second is around supporting the operator technician, the individuals that are actually going to use and operate the machines to replicate parts. And so the first thing I want to talk about with the how is that when using additive manufacturing, the big picture is to think differently. This is an Apple ad from the 90s, I remember. And the idea is that designing for additive is radically different than traditional manufacturing and designing for traditional manufacturing, where you're thinking about cost. With design for additive, you're thinking about function. So it's a big part of it is thinking about how do we change our mindset, and how do we start asking questions like, why do things need to be solid? How can we lightweight? How can we make things that are lighter and still stronger with different kinds of structures? Why do holes have to be round, or why do we even need a hole there at all? Can we redesign it without a hole? And why do we need to manufacture in assemblies? How can we think about, reducing the number of parts? And I would posture that the true benefits of 3D printing will happen when we start to design things that look radically different than anything we've ever created before. So this is an example of 3D printed glasses. On the one hand, the black glasses, they're traditional, right? And on the other side, you have the 3D printed ones. And they have taken advantages of some of the, the advantages of 3D printing. So for example, it's customized. Somebody's face was scanned. These glasses fit your face perfectly, specifically your face. It's also only one part instead of three. So there are no more screws. There aren't three pieces. There's kind of a flexible hinge to the glasses, and they were printed all in one part. But they look pretty much the same. In contrast, we have this, which is a 3D printed car chassis. It's a race car chassis. On the one side, you have the traditional race car chassis. On the other, you have a race car chassis that was built using generative design. So it's an algorithm. The algorithm sets the framework for how strong it needs to be, how much material to use, what are the forces it needs to accommodate. And you'll see a part that looks very, very different than the original. It's just as strong. It helps to optimize, make the race car faster. And I think this is where we're really going to see the future, is when we start understanding how to design things that look radically different than what we currently have. So we asked a number of different industries. We talked about 120 people from across 30 industries or 30 companies. You know, if you had to project into the future the things that you want to do with 3D printing over the next 3 to 5 years, and then the skill sets that you need or are missing in order to do that, what would you tell us that you need? And we identified 9 high priority unmet needs. And they're bucketed into kind of 3 broad topics. The first being AM economics and understanding kind of what the ROI is and how do you make decisions around ROI for 3D printing. The second is around advanced manufacturing, additive manufacturing design, and how do you really get that design for additive mindset. And the third is around the technician operator, understanding part quality assurance, processes, how to choose which kinds of process you're going to use, and how to actually, use the machines and print parts. So from that, we started thinking about, how do you use workforce and education for this? And it's not just about building knowledge and awareness, which is kind of what we're doing today, kind of building some literacy, but it's about building that hands-on skill and then applying that hands-on skill to industry applications. So, at America Makes, we developed something called the Academy Program. And the Academy Program is the advanced curriculum in additive design, engineering, and manufacturing innovation, neatly bucketed into an acronym. And it was developed with our members, so developed with companies like GE, Arconic, Autodesk, 3D Systems, Stratasys, to really get best-in-class information on how to introduce this technology and leveraging case studies. The very first academy we launched with the Air Force, AFRL, and they were specifically interested in understanding how to leverage and optimize 3D printing to redesign engine parts. So how to optimize engine parts. The program is built off of a lecture lab print format, and so it's case study focused, and we can tailor that case study to any industry. So if you come in with a particular part or a particular idea of where you want to introduce additive, the course can be built around how to teach the skills to build that part. So for the Air Force, we really focused on AM processes as it related to metal. So processes for metal, design for metal. And so this is a small example, a little taste of what we did in that particular class. One of the learning tools was using this hexapod robot to teach 3D printing skills and additive. Well, why do we use robots? It was because we're moving now from project-based learning to systems-based learning. And a robot is really a great way to teach systems-based learning. We can teach within a robot how to lightweight. We can teach how to leverage 3D printing to make balance components, to talk about load performance, end of arm applications, custom enclosures. So it really gives you a broad opportunity to think not just about the part you're making, but how that part fits in the entire system. Because it's not just about the part, it's how the part fits in the entire system. And so this is just an example of the leg. You'll see on the one side, you have the, on my right side, I believe, the traditional approach. So that's kind of what we call the dumb leg, right? There's no optimization there. Then we move into the semi-intelligent, where we start, having basic optimization. And all the way on the other side, you've got intelligent, informed, smart optimization. It's optimized specifically for additive. It's lighter. It's stronger. And this is just a basic robot leg, but how can you then apply that, to larger problems within your value chain? So the second example of a program that I wanted to share with you is called Apprenticeship Works. 2 years ago, the DOL provided a grant to RCBI, which is the Robert C. Byrd Institute, and they were able to partner in collaboration with America Makes, with SME, which is the Society of Manufacturing Engineers, Tooling U, as well as West Virginia Women Work and NCATC, which has been very, NCATC is an association of community colleges and technical colleges across the country. And the focus of this particular program was to help to support advanced manufacturing apprenticeships. And one of the focal points was to create an apprenticeship program specifically for additive. So these are the occupations that they're currently focused on. You'll see additive manufacturing, 3D printing technician is one of the core ones, but they also have welding machine operator, assembly technician, industrial manufacturing production technician. And so for the additive one, we took a customized approach, and we worked with, a number of different companies within America Makes to understand how could we create a customized additive manufacturing apprenticeship that would help to, meet your needs in terms of teaching individuals how to which technology to select, which process to select, how to do the build orientation, how to do supports. When we were working with the Air Force, for example, if you're going to print something in titanium, the way that you orient the part really decides whether or not the build will print properly, right? And so if you make a mistake, it's a really expensive mistake. So how do we teach that up front? Through things like apprenticeships. Also things like post-processing, making sure your parts are high quality, and doing all of that within a safe environment. And what is a registered apprenticeship? Well, a registered apprenticeship is a combination of on-the-job training and related instruction. So you bring apprentices into your companies, they get on-the-job training at your company, and at the same time, concurrently, they're getting related instruction and skill building through an academic institution, whether that be a community college or a certification course, or sometimes a university. They're also linked to national occupational credentials, so it's a portable credential that your employee can then take with them. And, just a little bit more about why apprenticeships. Every dollar invested in apprenticeships leads to a public return of approximately $28 in benefits. It is, for the employees, it leads to increased skills, higher wages, career advancement, safer workplace. And we're also seeing that, you can get knowledge through an apprenticeship in ways that you couldn't. You can get that hands-on competency and skill linked directly to industrial experience in a way that you couldn't in any other format of training. And for the employers, it leads ultimately to higher skilled employees, also to reduce turnover costs and a more diverse workforce. So the RCBI grant, that's through America Makes, if you're interested, they actually have a framework by which they can help you to select apprentices, to support the on-the-job training, and to identify experienced mentors to work with the apprentices. And they have consulting services to help you develop and implement that program. And again, the framework for the additive technology has been built by America Makes, with RCBI, SME, and a number of different organizations. So I think that I will leave you with that, with kind of those three high-level thoughts, which is first that if you want to integrate additive manufacturing into your value chains, think about how to design for additive. That the way that we design for additive, things will look radically different. The things that we design for additive should look radically different than they now currently do. And if you want to understand a little bit more about how to train your workforce to do that, there are a number of different programs that can help with manufacturing engineers, materials engineers, or product designers through the Academy program, or consider integrating an apprenticeship program to help to support and train your technician operators at your companies.